Hello. Today I'd like to show you how I go about doing a two-sided, or what they call flip mill job on using my desktop CNC mill, carving the milling this model in the hard wax, jeweler's wax. I'm going to show you how I set up the X, the Y, and the Z axis to 0, 0, 0 on the mill. The test that I do, how I do approach it in order to be able to do a double-sided flip mill like this where both sides align perfectly. I'll be walking you through the steps, and if I make any mistakes on the way, I'll try and correct them and as we go. So let's get started. Now here's a representation of simple representation of the mill and the rotary axis portion of the mill. This is a 4-axis mill, meaning that it's able to do a rotation on the A-axis. What we're going to do, we're going to align the Z-axis, which is up and down, and the Y-axis, which runs this way. We want to have our tool bit, so to speak. We want to have that perfectly lined up and in the dead center, or what we call 0, 0, 0 here. And in order to be able to do this milling, these have to be set right, or your milling job will not turn out. You'll be askewed. One side won't line up with the other side after you're done milling it. So what I'll be using is, this is a piece of jeweler's hard milling wax. It's probably about anywhere 4 to 6 millimeters thick, could be thicker depending on what type of job you're going to do. And this is probably about 2 inches wide and probably 5-6 inches in the length. Now I have a 4-jaw chuck here to hold the wax, and if you don't have a 4-jaw chuck and a 3-jaw chuck, you might want to make sure you have the fixture that will correctly hold a wax slab like this. Or with my mill, I have a rolling mill. I was able to make an adapter where I could take off the 3-jaw chuck that it came with, and I put a shear line 4-jaw chuck in there. And so when we put it in, it's probably going to be not level like this. So first of all, we want to get this level, and before we can start doing any milling, and this test it can be a simple test that you can run it to get everything to line up perfectly for you. Now what I have here showing is I have a little bubble level, so I rotate my A-axis to where I think it looks somewhat level. I put my bubble leveler on there, indicator, and I'll rotate the A-axis until it looks the bubbles fairly in the middle. It doesn't have to be exact at this point, for this test or anything, but even if it's not quite exact, get it as close as you can when you're doing your normal milling, as the mill job will straighten itself out in the end. When it's all done, it'll all be fine. So now we have the wax parallel there to the table on the milling base. What we want to do, we're going to want to, this is my spindle. I have a 1/8 of an inch end mill in the spindle, and we're going to you're going to jog it over here, jog it over and try and find out where you guess that this center point is. It's going to be a guess. Eyeball it up, take a look. It doesn't have to be perfect right now. It won't be perfect, to be honest with you. So what you're going to end up doing is you're going to jog lift up the spindle and jog it over to the wax where you think it's the center line would be. And don't go too far in, because we're going to drill a hole through here, and we'll have to do a couple tests down the line. So we'll start close to the end on this one. So there was the spot that I guessed. Okay, we drilled a hole through it now, all the way through. Now you're going to want to lift the spindle straight up, so it's off the way out of the way of the wax, all the way to the top if you have to, and you're going to rotate your A axis. You're going to rotate 180 degrees. Now the thing about this wax, if it's too wide or too long, too wide this way, and you try and rotate it, and your spindle's up in the air, you might hit the bit. Example, if you put this in lengthwise, this piece of wax lengthwise, it might be too long, and it would hit the spindle when it's up in the air. So you want to make sure you can mount it either way you want, but make sure whichever way you mount it, if you mount it the long way in the chuck, if it's too long, it'll hit your spindle. So just be aware of that fact. Okay, so we drilled a hole, and then what we're going to do, you're going to flip it over raise your spindle and flip it over 180, and we're going to drill a hole again, but not all the way through this time. So there's my hole all the way through on side A. The spindle is lifted up higher, so we can rotate to get to side B. Now, this is side B over here, and we're going to just lower the spindle down so it's about 1/16 of an 1/8 of an inch deep. We're not going to drill all the way through. As you can see, about this far on side B. Now drill your hole, and let's look at what we have here. So as you can see, we're off here. The holes did not line up. I highlighted this in red so you can see how far it's off. What we have to do here is, this could be on this side or it could be the other way off. Either way, it doesn't matter. It will look something like this. Now you're going to take this measurement from this here to this area, and you want to write that measurement down, because what you're going to do, you're going to take that measurement and divide it in half. Now you're going to rotate back to side A. And let me go back to side A a second. You're going to go back to side A, and you're going to take half of that distance, and you're going to jog your mill in the Y direction, the Y direction being this direction, that half of the measurement there, and then move your spindle over, and we're going to drill another hole right here. And you're going to do the operation one more time. Side A all the way through, side B only a little way through. Look at the model, your hole again. If there's a little bit left, like a little bit, again, half the distance, rotate it over, you jog it over that half of the distance. And this might take you a bit of figuring out which way you have to jog your mill, okay? But anyway, you're going to do the side A and the side B milling again, the hole milling, and you're going to inspect it until finally you get the holes lined up perfect. As you can see, I started here, and I had to do several tests in order to get the perfect hole. That's what you're doing here. That's the first part of the test. This meaning now that your side A, or not your side A, but your Y center, the Y center of the spindle is perfect in line. So once you get this set up perfect, that's your Y. Re-zero it out now on your in your software, your milling software, so that's now zeroed out. And do not touch the Y. Never touch the Y. If somehow you do something wrong sometime and you move the Y by accident, you can always go back and on your software set it to 000 again. It should line up, but you might want to do this test again just to be sure. But never adjust the Y. So now we're going to find the Z-axis. Now finding the Z-axis, you're going to have your spindle over to the far edge here. Move it over, and then line it up where you think, where the z-axis is a depth. We want to find the exact center line of the depth. That so we're right on the money with the 0 on that. So you make sure your mill is jogged over now, and you have the old piece of wax there that you cut the holes out of. If you have any left over, cut that off, and so you start with a fresh piece of wax. But when the spindle is over here now, turn it on. Let the spindle turn that on. Make sure it's running. After you've tried to figure it out, you're going to try and figure out before you start off to the edge here with the spindle. So you're going to try and by eye figure out where you think the middle of this is going to be. If it's a square block, if not, just try and find out where you think the middle of the rotary is. Then you're going to lower it down while it's over here. Lower it down, and then turn it on and jog it in to the wax. But you don't go too far into the wax because we don't need to see we don't need to go all the way through or in too deep. We want to have this edge showing so we can take a look at our results. So I did the cut. Jog your mill back like this, so it's out of the way. Then rotate it 180 degrees for side B and do the cut again. Just in the X direction, move it over. I have it like this, ready to go. So now I'm going to get ready to I turn the spindle on, and I'm going to cut into side B now. There, I've cut into side B. Now we're going to jog the mill back in the X direction and take a look at what we have. Well, wow. We can see that if you have a result that looks something like this, it could be thicker, could be thinner. Or if you don't have anything that looks like this. If you don't have anything that looks like this, your Z is too low. So you'll have to raise up the spindle. And if it's like this, you're going to have to lower the spindle for these next cuts. And you're going to try and hit that, mill it down by side A, side B, until you have a very, very thin wafer showing, not a thick piece like this, the thinnest you can get it, but you have to have a thin piece. If you have nothing there, you're still too deep with the Z, so you're going to have to raise up your spindle again. What we want to get, so I'm showing here, but before now that you looked at it, you're going to want to trim off that piece that you just cut that well into. Trim it off, remove it from the wax out of here and trim it off with a saw. I use a band saw, but you want to start with fresh edge there. You're going to jog the mill over, move it over again, not jog it over, or you're going to raise it up or lower it down, whatever you think you need to do. Then turn it on and jog it in and repeat that cut. There it is. This is my new cut now. You'll notice it's that deeper because I had to take out, I know I had to go deeper to try and remove that. Now, you jog the mill back again to the right, rotate it to side B, and do your second cut. There's my side A. Again, one more time so you can see that. Here's getting ready for side B now. I jog the mill over, the spindle, and I'm going to do my side B cut. Side B cut. Now let's take a look at what I have. You can see already that it's thinner, but there's a wafer in there. But we want to look at the side view of it. I'm just showing you there's a little wafer, and let's see if we have the side view. There's the side view of my second, or not my second cut, but this is what you want to achieve. A thin as paper piece there, as thin as you can get it. Once you have it like that, thin, as thin as you can get it, that's your Z depth. So go ahead and set your z-axis, reset it so it's at 0, and you'll have your y-axis, which is this way. You have that dead center lined up, and your z-axis is now in the exact middle of the A of the rotary spindle. Okay, now we've got our mill lined up. Let's bring our model in. Now this is a model that I designed, and I want to show you just a few things about it. When I design, or when you design, I try to start off these blue line and the yellow line. That represents the axis center point, what we call 0, 0, 0 of my design software. Now, when I design, I go equal distances. As you'll notice on here, this yellow line, if I had to extend it all the way through, it would run exactly through the middle of my model. Then you'll see it here. It's exactly through the middle. You don't want one half, for this particular, you don't want one half higher than the other off the 0 plane. You want everything to line up, so when you're working and you're designing everything, you've got the equal. If that's the case, one side you might have a different type of design, but where one thing you want higher on one side than the other, that's different. But that's basic modeling, is to try and keep everything lined up through the middle the best you can. Now we have to make supports. Okay, we have to add the supports because we're going to mill this in the wax. And if you just tried to mill that straight in the wax without any supports, the piece would fall out of the wax because it's going to be centered in the wax, and it's going to be cut away from the wax, and it would just fall out, and you wouldn't have a good mill. You would destroy it. It wouldn't turn out, basically. So what I'm going to do, we have to make the supports and add them around there. Now, I drew a little box square representing the support. Now again, the support is right here, and it's right on the 0, 0 line. This is on the 0, 0 line. You can probably see the yellow right there. Right there, that's the middle of the model. That's what you want to begin with. It's going to be a curve, a connected closed curve. Now we're going to extrude that curve to make it a solid piece, and that's what we have here. That would be my first support. Now you want to go around and start making you want to start making these supports where you think they're necessary. Let me show you what mine looks like, how I designed mine. So first of all, I took this yellow line represents the piece of hard modeling wax, which is wide enough and thick enough and long enough to hold this model here. So once I have that in, I know the barrier, so to speak. So I designed my supports accordingly and how I needed them, what I thought would work out. So now what I do, I would extrude this block, this curve into the proper thickness of the wax I'm using. And before I do that, I want to draw a line. Here's again, that represents my block. So the line around here is I'll show you. I'm going to use this, but notice that they're only going about halfway or so, not even that much on some, but through the supports only. Now I will extrude the cyan colored line to represent my block of wax. Now there's my block of wax that I'll be milling out of, and you'll see my supports. This is an X-ray, so you can see it, ghosted view. You can see my supports here and a black line. And again, now this black line right here, I'm going to extrude that so it goes through the wax, and I will then I will delete the bouillon difference, they call it. Well, I'll take away the part that this extrusion here. I'll take that part, I'll cut that part out from the block of the wax. And I don't know, I have that there, but we'll get back to it. I'll get that. Okay. Now there's extruded that curved line, and it goes through both parts of the both sides of the wax. I extruded it on both sides at the same time, so the upper half and the lower half at the same time. I'm now going to bouillon difference, which means I'm going to take away. This is going to slice through the wax and take away the that section there you'll see here. So it sliced it through and it took away that section, and this is what leaving me with this. I changed the color background so you could see it. Now this would be able to be printed, or milled, just like it is. And then we'll go to saving the file, the whole piece. We're gonna highlight it and save it as an STL file so we can mill it. Now we've got our rotary axis in line. Everything's 0, 0, 0. I have it chucked up into my wax piece, chucked into my mill here. And now my spindle on this particular job, I have a bit in there, and that's what they call a .010 tapered ball end bit, which you can get those through Bits and Bits or any companies that sells these micro bits like this. And then we're going to jog in the X direction in this factor. Either way, it doesn't matter. We can line it anywhere you want to, but because the machine will automatically do the double side flip, the mill, and milling it will turn out right. But I like to go in the center and calculate approximately where the length of the actual piece is going to be, so you'll have enough room here left over. You've got to have a little bit left over here. You can't just cut through the ends or the sides. You have to have the model connected to the inside of the wax piece, or it's just not going to turn out right. And then we're going to proceed to do the milling. Here it is. I'm showing you what the piece, what is X-rayed, so what it would look like, so you could figure out where you want to start that center off this bit here. So I put it like right there before I started my milling. This is just so you can see what's happening. Now, I cut out. Let me go back here. I did cut out one time. I did cut side A out already, and I just want to show you. I changed. It's only milling half of the model, the top half, and this blue or purple. I changed purple there, the surface there of the wax, bottom half of the wax, to show you that it only milled the top half, and you could see half of the support is there on the top, and the bottom half, you can see of the bottom half is still there. This part is all will be milled out. So just showing you that it cut half, exact half of the thickness there. We flip it over. Now we do side B, and we mill it all out. And when side mill piece B is done, that's what it'll look like. You'll notice it's all cut out. I changed the background so you can see the color of the, see it through. It cut all the way through, and it left you with the model attached, still attached to the wax slab block. Now we're going to remove that wax. We're going to have to remove it out. What we're going to do is we're going to take it off of the mill, And you're going to take a little tool, a little saw or a little bit, and you're going to slice through those red supports there to release it from the wax block. Again, we got it off the right now. This is what it looks like once you take it off the mill. You'll have this, and that's when you start slicing your pieces to release the model. So I released the model now, and now you still have the leftover tabs that we cut through. Now your next job is to remove those tabs with a little saw or little files, and try and keep it real nice and clean because you don't want to cut into your model at all. So you got to finish removing off the rest of those by hand. Now that's what you have. That's your finished model. Now you'll see these holes right here. Those holes, since it was a two-sided mill, it won't cut those milling job. It won't cut those holes out. However, if you were to take just the gun part or the model itself, and you could have added some supports for 3D printing and set everything right, you will have all these holes this way. But that's it for 3D printing. This is for the CNC milling, so you won't see any of this, but it'll look like this on both sides. And this will be flat filled in because it can't mill. The mill won't mill sideways through there. So we have that. So that right there, if that's the way you want it, you could cast it into gold or silver, and that would be the finished piece, add a bail, and have a chain for a pendant. There's the milling job. This would be side A and side B. They are both lined up perfect, as you can see. Everything's lined. If they were skewed, one half would not be perfectly lined up with the other half. You'll notice when I was making this the captures, I forgot to capture the little screws there. So if you don't see them, it's because I forgot them when I was doing this. And we'll see how we got here. So that is the milled piece. Now all I have left to do is cut off the sprues, like I showed you, and then that's ready for casting in gold or silver. And I'm not going to do that right now because this is something I'm just saving it like it is for the show. But I'll probably do it one time in the near future, cast it. And there you have the finished render. If I was 3D printing it, again, I would have all these in here. But if not, this would all be closed up because the milling couldn't do it. But the gun would look like that. I happened to mill it a different way. I did the handle part in a different milling, but it would all be solid, whatever, gold or silver. And then if this is a different thing about having a different color handle like that, I added a bail and a chain through there, and that's the finished piece in a rendering. That's all lined up. You can see everything is perfectly aligned. Now, I hope that I've been able to help you so you can successfully start doing 2D flip milling jobs. If you have any questions or anything, feel free to leave a message there. And down below or wherever, message me, and I'll be more than glad to help you out. Once again, thanks a lot for watching.